Namaskar, Jai Guru. I am Ritesh Kumar Pathak, Department of Physics, Intermediate Wing of Yogoda Satsanga Mahavidyalaya. In the last lecture, we have studied about the Coulomb's law and its vector form, and we have drawn the formula for force of attraction or repulsion between any two charges. In this lecture, we will study about principle of superposition of charges. Whenever there is a number of charges, there will be a different types of force of attraction or repulsion among the charges present there. So if we select any one charge out of them, then what will be the net force on that particular charge? The idea of net force will come from the principle of superposition of charges. Here we will discuss that. Here let us discuss about this statement first. If the system contains a number of interacting charges, then the force on a given charge is equal to the vector sum of the forces exerted on it by all the remaining charges. In the diagram you can see I have taken three charges, namely Q1, Q2 and Q3, and these are making a system. Here the force on Q1 due to the charge Q2 is represented by F12, and the position vector is given as R12 vector, whereas the force on charge Q1 due to charge Q3 is given by F13, whereas the position vector is given as R13. That means there are two different types of forces acting on charge Q1 in two different directions. So from the parallelogram law of vector addition, we can calculate the net force acting on charge Q1 due to rest two charges, that is Q1 and Q3. So F net is given by the sum of F12 vector and F13 vector. Similarly, if we have the system containing n charges, then the net force acting on charge Q1 may be represented as F net equals to the sum of F12, F13, F14 up to F1n. Let us understand it by some examples. Here I am reading the question first. Try to understand it properly. 4-point charges QA 2 microcoulomb, QB minus 5 microcoulomb, QC 2 microcoulomb and QD minus 5 microcoulomb are located at the corners of a square ABCD of side 10 cm. What is the force on a charge of 1 microcoulomb placed at the center of the square? Here you can see there are group of charges and we have to calculate the force which is acting on charge at O. So here we will apply the idea of principle of superposition. For that, first I have calculated length of diagonal of a square, and which is AC and BD equals to under root 10 square plus 10 square from the Pythagoras theorem for right angle triangle, and equals to 10 under root 2 centimeter. From there we can calculate OA equals to OB equals to OC equals to OD, and finally it is equals to 10 root 2 upon 2 equals to 10 upon under root 2 centimeter, which is the distance from the charge which is as center to all the remaining charges which are located at A, B, C and D. So the force of repulsion on charge at O due to charge at A is given by Fa from Coulomb's law, 1 upon 4 pi epsilon naught, 1 into 10 to the power minus 6 into 2 into the power minus 6 upon 10 by under root 2 whole square Newton, as it is a force along A to O. Similarly, we can say that the force of repulsion on charge at A due to another charge which is located at C will be of equal magnitude, because these two charges which are at A and C have the equal magnitude of charges as 2 microcoulomb and 2 microcoulomb each. And also these two charges are positive in nature, so they are repelling the charge which is at O in opposite directions. Since these two forces acting on charge at O are equal and opposite, and therefore they will cancel each other. In the same way, if we calculate the force of attraction of charge at O and the charge which are located at B and D, as they are negative charges, they will also equal and opposite, and therefore again we can say that they will cancel each other. So finally we can say the net force on the charge of 1 microcoulomb which is at O is 0, and that will be our final result. Here we take another example. 3 equal charges 2 into 10 to the power minus 6 coulomb each are held fixed at 3 corners of an equilateral triangle of side 5 cm. Find the Coulomb force experienced by one of the charges due to the rest 2. Here I have taken 3 charges as Q1, Q2 and Q3, each having the magnitude 2 into 10 to the power minus 6 coulomb. The distance between any of them is 5 cm, which is converted into meter as 5 into 10 to the power minus 2 meter. Now we are going to calculate the force on charge Q3 due to the charge Q1 or the charge Q2, as from the Coulomb's law, F1 equals to F2 equals to K into 2 into 10 to the power minus 6 coulomb into 2 into 10 to the power minus 6 coulomb upon 5 into 10 to the power minus 2 meter whole square. After calculating, we get the force as 14.4 Newton. This is the force which is acting due to the charge Q1 or to the charge Q2. Now we can see these two forces F1 and F2 are in different directions, and hence for finding the net force which is acting on charge Q3, we have to apply parallelogram law of vector addition here. For that, there is given thing, these 3 charges are located at the vertices of an equilateral triangle. So the angle between the vector F1 and vector F2 is 60 degree. Therefore, the resultant force, which may be written as under root F1 square plus F2 square plus 2 F1 F2 cos theta. We can put F1 in place of F2 also, as they have equal values. So after calculating, we get the net resultant force as 14.4 under root 3 Newton. I hope this has given you the idea about principle of superposition and its application on numerical examples. If still anything is unclear about the topic discussed here, please drop your doubts in the comment box and don't forget to share it if you really liked it. Thank you. Jai Guru.